Now that we've done integrals, what we're going to do now is delve into the world of double integrals. We'll spare you triple and quadruple integrals, but for now let's take a look at a double integral. So set up this 2y dx dy. So we have double integral 2y dx dy. How these are set up, we've got an inner integral. So we're finding an integral with respect to x over these values. And then we've got the second integral, or the outer one, with respect to y. So the first thing we're going to do, have a two-step process. So the first thing we'll do is find the integral, the integral, 5 times fast, say that. Integral, yeah, you can't do it. Anyhow, luckily they're easier to solve than to speak. So the first thing we'll do is we're going to find the integral with respect to x evaluated from 0 to 1. So let's leave the stuff in terms of y alone. Basically, we're finding the integral from 0 to 1 of dx, or 1 dx, which is x evaluated from 1 to 0, which is simply 1 minus 0, or 1. This value then goes back into the outer integral, and we get integral of 2y dy, which is y squared, evaluated from 3 to 0, which is simply 9 minus 0 over 9. So that's the solution to the double integral. So again, we take at the inner with respect to x, the outer with respect to y. Take the integral of dx with respect to x, find its value, plug back in for the outer integral with respect to y, and find its integral. So let's try another. I've got 1 to 2, negative 1 to 3, x squared y dx dy. So the integral is based on x. So what's going to be left will be the outer integral. And we're going to evaluate the integral from negative 1 to 3 of x squared dx. And that will be x cubed over 3, evaluated from negative 1 to 3, which is, so if we take this over here, we get 3 cubed over 3 minus negative 1 cubed over 3 which is 9 plus 1/3, or 28/3. So this value then goes back into here. 28/3 times y dy, which will give us 28/3 times y squared over 2, evaluated from 1 to 2. I'll take this back over here. So that's going to be 28/3 times 2 squared over 2 minus 1 squared over 2. 28/3 times 2 minus 1/2. 28/3 times 3/2. Canceling. And we get 14. So again, we start with the integral, which is based on x. That integral, x cubed over 3, evaluated from 3 to -1, which is the range for x, determined here by the integral. Evaluating that, we get 28/3. 28/3, the value of the integral is put back in. Since the outer integral is evaluated, and then a little algebra to finish off. Let's try one last one. So here we have a double integral. It starts out with a function like this. What we're going to do here is simply do a little distributive. So 3x times dx dy plus y times dx dy. What that's going to give us is two double integrals. 3x dx dy plus y dx dy. And so this is going to involve finding two double integrals and finding their sum. So first one, we're going to add to that the value of the second one. So same steps, we're just going to do them twice now. So do the inter first. That's the integral of -2 to -1 of 3x dx, which is ½ x squared, evaluated from -2 to -1. That's 3/2 times -1 squared minus 3/2 times -2 squared, which gives us -9/2. So then the outer integral is negative 9/2 dy, which is negative 9/2 y, evaluated from 5 to 0. And I'm going to bring this over here, so that's going to be negative 45/2. That's the value of this first integral. Now for the second, we're going to have find the inner first, which is 2 to negative 1 of dx, which is x evaluated from negative 1 to negative 2. That ends up being negative 1 minus negative 2, positive 1. This value gets back in here, so we have 1 times y dy. That integral is going to be y squared over 2, evaluated from 5 to 0, which will give us 5 squared over 2 minus 0 over 2, or 25/2. So that's the value of the second integral. And when we add those together, we get negative 20/10 or negative 10.